In a proof. What's the first column called? Statements. And the second column? The second column is called what? When we do statements and reasons. Good. We have statements and reasons. Okay. You need a pencil. All right, statements and reasons. So today we're going over a little bit more of those reasons, where we're getting what we're going to use in that idea. Tomorrow we'll actually start doing proofs. There is one proof in your practice today, but it's a two-step proof, so it's not really a full proof because you're just going to put the given in there, and then you're going to put the proof in there, and you're going to have one reason you have to come up with. Super hard, I know, but you can do it. Alright, so today we're going to talk about converses. So we're doing a way back Wednesday, going all the way back to converse in beginning of chapter 2. So either you can flip your notes to this one, and you can find converse there. Or you can look up on the board, it's above the TV, converse. What does converse mean again? To switch. Good. So that picture up there says converse, and then it says verse con. It's switching places. So converse means to switch places. We use these a lot in geometry. That's why we learned it in chapter 2a, because we do a lot of converses. So we're going to switch places. Okay, which tells me if I have an if-then statement, if A, then B, we are going to switch it. So what would the converse be? If, what part would I start with instead?
If B, then A.
Good. If B, then A. Nice, Jordan.
Wait, wasn't that if you switched around too?
Nope, the if always stays with the hypothesis at the beginning part. Because it's just the fragments. The if and the then stay there. Alright, so that's what we're doing today. Today is going to feel a little bit like review, especially if you've been paying attention in 3-2. If we flip back to 3-2 just for a second, that's this one. With all of these. Okay, we're doing converses of these. So when I look at my corresponding angles postulate, that tells me if parallel lines are cut by a transversal, then the angles are congruent. Okay, but starting with what? Parallel lines. Remember we did those little marks on them to show that they were parallel first? Then we said they're congruent. We're going to do, not a fidget. The scissors is not a fidget either. You can put the scissors down.
So no sharpening pencil?
Nope. Okay, so we're going to be doing the converse. So instead of starting with parallel lines and then saying they're congruent, we're going to first say these are congruent. Now what? Now the lines are parallel. We're just going backwards. Okay, so as we take a look at these, all four of these, rather than writing it out 4 different times, they all start with saying if 2 lines are cut by a transversal so that, and then you pick one of these 4. If one of those 4 happen, then the lines are parallel. So we're going to start with corresponding angles. What relationship should corresponding angles have? We just looked at it. They should be congruent. Thank you. Okay, so corresponding angles are congruent. Okay, so I have 2 lines here. I don't know that they're parallel. They look parallel, but we're not for sure that they're parallel. We don't have the marking saying, yep, they are parallel. But what I do know is that corresponding angles are congruent. So I'm going to mark those corresponding angles. So if I mark this one here to start with, I'm going to do a little arc because that shows us that angle. I need to mark the corresponding over here. Remember, corresponding means matching. It's not inside or outside. It's that they're matching. So am I going to go to the left or to the right? To the right. And do I want to go above or below to match? Above, yep. So those are matching. Those are corresponding. As you take out your color pencils, we need 2 colors today. So if you want to grab, let's do green and what other color? What color do you guys want? Green and?
Purple.
I don't have pink. I don't have purple.
Why don't you have purple?
Because that didn't come in the pack. Blue? Green and blue?
Knockoff crayons?
Yes, because they're cheaper. And people lose them and they break them. And I have to buy them with my own money.
Well, why didn't the school buy your markers?
Because it's not in the budget. Alright, here we go. Alternate interior angles. So now alternate interior angles. What do we know about alternate interior angles? What kind of relationship should they have if we go back to 3-2? Joe, put away your phone. Abdi Majid. Thanks. Appreciate it. Not very sneaky. Alright. 3-2, what does it say for about alternate interior angles? They're congruent. Good, congruent. Okay, so I have 2 lines here that maybe look parallel, but I don't know that they are parallel for sure. They look like they might not ever intersect. I have a transversal, so 2 lines cut by a transversal. I have a line going through them. And this time I'm looking at alternate interior angles. So I need inside angles. Earlier today I had a student ask me, how do you know that they're inside? And it's like if you put your fingers on the lines and you pinched them together, the inside is the pinched part. That's our inside. Okay, so if I start with this line, or this angle here, I just picked in one of the inside ones. It's also in between the lines. Alright, when I do alternate interior down here, do I want angle 1, angle 2, angle 3, or angle 4? Which one would be the alternate interior? 1, 2, 3, or 4? 2, good. Okay, we're inside, and then we want opposite. So not below the transversal, we want kind of like above the transversal. Okay, and those are congruent. They're the same. They match. All right, next up we have consecutive interior angles. This is kind of the oddball out. Does anyone remember what is the relationship that consecutive interior angles have? You can flip back to 3-2. Supplementary. Thank you. Supplementary. And supplementary means they add up to what? 180. Nice. Okay, so if I draw those 2 lines that look parallel, but I don't know for sure. Those don't look parallel, but just pretend. Okay, I draw a transversal. I draw a line that cuts them. Now this time I want consecutive interior. So I'm still looking inside. So if I look inside and I pick this one here, okay, now I want the consecutive interior. So I go to the other intersection. Do I want to go above or below? Above is interior? This way? No, below. I want to go below for interior. For consecutive, though, do I want to kind of go to the left here or to the right?
Right?
Yeah, kind of to the right. It's kind of goofy because it's kind of like down and right. But these are not the same, so when we mark it, remember this time we need to use 2 arcs. We can't just do 1 arc and 1 arc. That would say that they match. And these do not match. They add up to 180. They could match, They could both be 90, but they don't have to be a 90 both. They just have to add up to 180 together. All right, and then our last theorem here, our last converse, is alternate exterior angles. And what are alternate exterior angles supposed to be? Congruent. I have two lines that definitely are not parallel. That was a terrible drawing. Whoops. Okay, we draw a transversal through those that are going to go through both lines. This time I want alternate exterior. So where are these lines going to be located? Outside, that's the exterior. Same side of the transversal or separate sides? Separate, good. So if I start with this one up here, okay, I have to go to the other intersection. Do I want 1 is alternate interior, 2, 3, or 4, alternate exterior? I said that wrong. 1, 2, 3, 4. 4, Tanner? Yep. Good, this one's on the outside. It's not between if I pinch these together. Not in between, it's outside. And then this one's kind of above, so we're going below. All right, so hopefully this feels a little bit like review so far. So our goal today is if one of these is true, one of these 4, then we know the lines are parallel. So that's what we're going to be doing today is we're going to identify which one is true and then which lines are parallel. So we have 3 examples here. As we work through these examples are independent of each other. What I mean by that is once we do number 1, we answer number 1, we pretend number 1 didn't happen. Now we're on number 2. And then we pretend number 2 didn't happen, we do number 3. These don't all live in the same universe. They're kind of all their own separate problems. But we're just using the same picture for convenience. So in this one we have lines A, B, and C. What's our transversal line? Which line is cutting those lines? Close. It looks like E. This is actually an L. That's why I wanted to talk about. That's an L. This is a C. I don't know. It's cursive. It's hard. This is supposed to be L. It's just a little bit more elongated. All right, so as I look at number 1, it says, are any of these lines parallel and why? In number 1, we have angle 1 and angle 4. Which lines would I be comparing with 1 and 4? A and B, A and C, or B and C? What would 1 and 4 tell me to compare?
A and C.
Good, why?
Because C is with angle 4 and A is with angle 1.
Good. A is with angle 1, C is with angle 4. So I'm actually going to cover up B. That helps me visualize this better, to get rid of the extra stuff. So now as I look at 1 and 4 with A and C, are those inside, outside, or matching? Inside. Now with inside, we have to decide, are they the same side or separate sides? Separate. So alternate interior or consecutive interior? Alternate. So they're alternate interior, and we're saying they're congruent. Is that one of the 4? Yep, right there. Alternate interior are congruent, then the lines are parallel. So what 2 lines did we say those go with?
1, A and B, A and C.
A and C. So we're going to say A is parallel, and we use these 2 little slashes for parallel to C. And then our reason why is we just named the relationship. They're alternate interior angles. But we didn't use the theorem. Today we use the converse. And that's really what we're doing in each of these. First, we're going to identify what lines we're looking at, and then what is the relationship, and does that relationship work? Is it what it told us it should be? So now when we move on to number 2, remember we're pretending now number 1 didn't happen. New problem. Number 2. Given that measure of angle 2 is 130 degrees, and measure of angle 4 is 53 degrees, what two lines are we going to look at for 2 and 4? A and B, B and C, or A and C? Yeah, B and C. We're looking at 2 and 4. So I like to put my pencil over that extra line and just get rid of it so my brain's not thinking of it. So when I look at 2 and 4, what relationship is that? Are they inside, outside, or matching? They're both inside, 2 and 4. Are they consecutive or alternate? Consecutive, they're on the same side, they're facing each other, 2 and 4. Okay, so consecutive interior, and consecutive interior are supposed to be supplementary. So let's check to see if these are supplementary. If I do 130 plus 53, is that equal to 180? Does 130 plus 53 equal 180?
No.
Nope. So I'm going to put a little slash through that equal, saying they're not equal. It's not equal. So I can't come up with a conclusion. I know for certain B and C are not parallel, but I don't know anything about A in number 2. So I'm going to just write no conclusion. I'm going to write it really sloppy. Okay, it didn't work. It was not one of those 4, so it's no conclusion. All right, last one, number 3. Try and work ahead here if you'd like to. First step is to decide what 2 lines we're working with. So number 3, we're working with angle 1 and angle 3. So for angle 1 and angle 3, are we looking at A and B, B and C, or A and C? A and B. So when I look at A and B with 1 and 3, are those inside, outside, or matching? Yeah, they're matching. 1 is inside. What about 3? Yeah, 3 is outside of A and B. So when I look at matching, which one meant matching again? Matching is our corresponding. They correlate. They correspond. They're matching in the same place. So corresponding, they're supposed to be congruent. Now in our information here, it doesn't say that they're congruent. What does it say? That angle 1 is 46 and angle 3 is. So are they congruent? Yep. So what 2 lines are going to be parallel? A and B. So A is parallel to B. We do those 2 little slashes to show parallel. Okay, A is parallel to B, and then what's our reason? Which one of our 4 are we using? Corresponding angles. Yep, and it's a converse. So corresponding converse. So that's what I'm asking you to do today. On 3-2, if you're like, why is this different from 3-2? 3-2, I was asking you to find the angle measures. And 3-5 now, I'm giving you the angle measures, and you're telling me if they're parallel.